Hello guys, in continuation with this section, we'll first talk about the types of model that we have in machine learning. The models are classified into two broad categories, namely tree-based models and non-tree-based models or linear models. Tree-based models work on splitting regions and work with multiple categories of data. They are capable of handling non-linear relationship among data, whereas non-tree-based models or linear models are capable of handling only linear relationship. They work with single type of data and are interpretable. Let's see some of the basic tree-based models and non-tree-based models closely. Decision tree. A decision tree is a super simple structure we use in our heads every day. It's just a representation of how we make decisions. As you can see on the left, I'm having a decision tree which starts with a question and some follow-up questions till we get the final answer. But how do we make these decisions? We have certain algorithms in ML that provides the decision boundaries in this algorithm. These are ID3 and CART. The ID3 algorithm uses entropy and information gain to define the decision boundary, whereas CART uses the Gini index for defining the same. A support vector machine is a supervised machine learning algorithm that can be employed for both classification and regression purposes. SVM is most commonly used for classification problems. SVM are based on the idea of finding the best hyperplane that divides a set into two classes. The margins here are termed as support vectors, which hold on the decision boundary between two classes. Naive Bayes. Naive Bayes is a family of probabilistic algorithms that take advantage of probability theory and Bayes' theorem to predict the tag of a text like a piece of news or a customer review. They are probabilistic, which means that they calculate the probability of each tag for a given text and then output the tag with the highest one. The way they get these probabilities is by using Bayes' theorem, which describes the probability of a feature based on prior knowledge of conditions that might be viewed related to the future. Naive Bayes works well with text data, and that's why it's quite popular in NLP or natural language processing. K-nearest neighbors. K-nearest neighbor is a simple algorithm that stores all the available cases and classifies the new data or case based on a similarity measure. It is mostly used to classify a data point based on how its neighbors are classified. Here we can see an example of classifying people on the basis of profession. So, the similar professional people are in closest to each other, meaning they are neighbors of the feature set alone. So, the k-nearest neighbor works in the same way for finding neighbors who are similar to their characteristics. Linear regression is one of the most popular techniques used in statistics. It assesses how successfully a predictive variable does its job in predicting the outcome variable. Here we're going to plot x values along the y values and define a regression line according to the correlation difference. Regression is quite famous in ML predictions. K-means clustering. Till now we have seen various supervised models, but K-means is a kind of unsupervised model, meaning there is no direct relationship between features and labels. So, how it works? It follows a simple procedure of classifying a given dataset into a number of clusters defined by the letter K. The clusters are then positioned as points, and all observations or data points are associated with the nearest cluster. The clusters are formed on the basis of certain characteristics. of data. Here in the pictures, the various group of data are grouped into clusters of various colors by finding out the centroid of each clusters. We have now seen various models that we can have in ML, but what to choose when? This graph is an ML algorithmic trade-off graph between interpretability and accuracy. The whole point of this graph is to tell you that various models are good in various conditions. But this graph is purely unscientific and opinionated. So it's better to try and understand a problem and then choose the right model.